Hey, what's up, everybody? Today's topic we will see what is MAC, what is flooding, and finally, what is ARP. So, first of all, we will see what is MAC. MAC is nothing but media access control, which is 48 bits long, or sometimes it's also said to be 6 bytes in length, so which can be separated into 24 and 3 byte and 3 byte. So the first 24 and the 3 byte or the 3 byte will represent the OUI, organizationally unique identifier, and the rest of the 24 or 3 byte will represent the unique serial number of the device itself. So now we will go ahead and see how does the switch will learn the MAC and flooding process and also the ARP by using an example. So I'm taking a device which is a switch, and I'm taking 4 PCs connecting together, switch, and also assigning IP address to each and every PCs. I'm giving 192.168.1.1. So as we have seen in the previous videos, the IP address plays a major role. I'm giving 2 for this one, for PC2, giving 3. And finally, for the PC3, I'm giving 1.4. First thing first, so what is flooding? Flooding, in a simple words, I can say the MAC address is not present in the switch yet. So this is a simple definition for the flooding. So in order to give you a brief definition for it, say for example the PC0 wants to communicate with PC3, but the MAC address of the PC3 is not present in the switch, then it will obviously, when a packet comes to the switch, it will flood the frames, meaning that it doesn't knows who the MAC addresses belongs to or the IP belongs to, so it is going to flood it. So that is so called flooding. So what do I mean by that is, we'll see by viewing the switch itself. So in the switch, in order to see whether any MAC address has been learned or not, we can type show MAC address table question mark will gives you more information. Type dynamic because it is dynamically learning the MAC addresses. So as we can see, the MAC address is not at learned, meaning that none of the PC is learned about each other. And to learn that is that the PC learned any of the MAC address of other devices, we can check it from our command prompt by using ARP-A, and now we can see there is no ARP learned. So now we will ping from the PC0 to PC3 and see how it works. So first of all, I would like to show you in the simulation mode so that you can see what is happening here, and then we will go ahead and try from the PC1 to PC2. Alright, so I'll take a packet and try to ping from PC0 to PC3, and I will start now. As you can see, the packet is going to the switch, and then it is forwarding. As you can see, this process is so called flooding. So instead of sending it to the specific PC, it is sending to all the PCs present in the LAN. For a brief definition, I can say when a switch receives a packet which contains the destination MAC address that is not in the switch MAC address table, the switch will forward out of every single port except the port which is received on. So this whole process is so called unicast flooding because the destination MAC address is not known yet. So now that we have seen in the real time, we will go ahead and see whether the MAC has learned that specific MAC address or not. So show MAC address table dynamic. All right, so we can see 9CDD and 6C60. We will see whether the MAC address belongs to those or not. We will copy them, paste it right here. C3. So as we can see here, so the 9CDD, which belongs to the PC0 connected to fast Ethernet 0/1, is learned here, and then 6C60, which belongs to the PC3, is learned from the fast Ethernet port 0/4. And also, if we want to see whether it is learning from this device, we will see ARP-A. So we have pinged the PC3, which has the IP address of 1.4. So it learned the IP address of it, and also the MAC address of it, which is nothing but 6C and 6D. So if you want me to give you a real-time example, let me go to the terminal of my computer and type ifconfig. Mine should be in the EN0. At least that's what I learned in Linux before. Copy, and then I'll try to look up in the get it here. All right, so I just typed MAC address lookup. So we will see in the first link. Let me paste it here. Search for it. So as we can see here, the MAC address OUI is this one, which belongs to Apple. So we have discussed it earlier, right? So the MAC address first 24-bit or 3 byte will represent the OUI, which is Apple, and then the rest of the 24 3 bytes belongs to my device itself, which is assigned by the Apple. So by this, we have known what is MAC and how does the flooding works. And now we will see how the ARP works. In order to see how ARP works, we will go ahead and clear all the MAC address which is being learned before. In order to clear that, clear MAC address table dynamic and show it again, and that's nothing. Since we have learned from here, we will try to delete them by ARP-D. And if you see whether it is there or not, there's nothing. We have deleted them successfully. And right from here, ARP-A, we will delete them, this one too. So what is ARP? ARP ARP. ARP is nothing but address resolution protocol, which will actually maps your IP address to the MAC address. It's simple as that. So the specific function of an ARP is to map or translate your IP into a MAC address. That's the function of the ARP is. So say for an example, if again we will see with the different examples this time. So for the PC1, we will try to get the details of the PC1, the MAC address of it, copying it and paste it here. For the PC2, copy the address of it, paste it here. So now we will see from the PC1 and PC2 for the ARP example. I'll give you a definition for this one too. So when a device, say for example the PC1 device, wants to communicate with another device which is PC2 on the same local network, it knows the destination IP address, right? So when you ping it, it knows the IP address, but it needs to send the packet to the MAC address, which is basically to the layer 2 device. So this mapping between an IP address and the MAC address is called ARP. So ARP is nothing but a protocol used to discover the link layer. So to find the link layer address associated with the IP address. And the ARP operates at layer 2 of OSI model. Perfect. So we have known what it is. So we will see an example for it. We'll go into a simulation mode, delete the previous ones, and pick up a packet. So I'm trying to ping from PC1 to PC2. So before that, let's see whether any MAC address has been learned or not. So MAC address table. So it is belongs to DD and 60. Since it learned before, it's still there. So we don't have to worry about that one since we are going to ping from PC1 and PC2. The record of it is not still here. And for the additional information, we can see it here too, whether it is learned or not. There's no information here. And ARP-A, no information right here too. All right, so let me just ping from this device, PC1 to PC2. So what happens now? So when ARP is happening, the ARP will be sent as a request. The ARP request is sent to the entire local network as a broadcast frame. Once it is sending, we will view that specific. I didn't mean to just send it, but excuse me. Stop there. View it. As we can see here, I am the one who is requesting for the MAC address of this one. So I'm pinging this one. So the destination address will be FF, FFs. So basically meaning that it is a broadcast address. So I'm sending it the request to everyone as a broadcast. Even in the interview, it will be asked you, it is asked, so how does a MAC learns or how does the ARP works? So you have to be clear with this statement, meaning that the ARP request is sent to the entire local as a broadcast. So once it is sent, next process will be broadcasting to every PCs. Once the PC2 receives, it will look into it and update its information in it, meaning that the IP address of this one and this one, 192.168.1.3, and the MAC address will be updated soon. As you can see in the outbound, you can see it is updating its MAC address too. As you can see in the outbound PDUs, I'm sending to the requester, who is 192.168.1.2, which is PC1, and the MAC address belongs to the PC1, which is B2BB. Let me play it again. It is going back to switch. We will view that outbound too. So now it is going to the switch, and once it is here, since the switch knows the MAC address belongs to B2BB, it will send it to the PC1. So at last the ARP is learned. So basically this is the process of MAC learning. So once we view it, you can see that this information came from the source IP 192.168.1.3, which is nothing but the PC2. Alright, successfully we have learned the MAC address. Let's delete the simulation mode, go to the real time, and see in the switch. We will verify this one in the switch by typing show MAC address table dynamic. You can see the switch has learned the MAC address of PC1 and PC2, which has B2BB right here with fast Ethernet 0/2, and the MAC address of PC2, which is 2030 right here with the port number fast Ethernet 0/3 right here. So once we have verified in the switch, we will go ahead and verify in the device itself whether it has learned the MAC address. Yes, it has learned the MAC address of the IP belongs to the PC2, as you can see here. And also we can go into PC2 to view the information. So it has learned the MAC address of the PC1 as well. So that's it for this video. This is the process of MAC learning. So thank you so much for watching the video. Stay tuned for the next videos as well. Until then, bye from Rogan.